This is my second video on graphing linear equations, how to do it quickly. In this one, we're going to focus on how to graph lines whose equations are listed in standard form. Okay, so in the last video, we talked about what we refer to as slope-intercept form, which is this y equals mx plus b form, where we were told the slope and the intercept of the line just by looking at those values. We're going to notice here that this is also a linear equation, but it's just kind of in an altered form. So we say standard form of a linear equation is this form ax plus by equals c, where c is some constant, so this has no variable. Okay, so constant. So I want us to notice that all the constants are on the right, and we notice that anything that has a variable term is on the left. Okay, but we say a and b are just the coefficients of x and y in this case, but we say a and b, we won't allow them to be 0. So if neither of them are 0, that means we have both an x and a y. If we have all of our variables on the left and all of our constant on the right, then what we have here is standard form of a linear equation, at least in this form. Okay, so we say constants. Anyways, the thing here is this. It's very easy to graph something out of standard form. We can just go ahead and take a look at an example, and we don't even have to make a table. Now, keep in mind, if I did want to make a table of this, or maybe if I even don't, but I do want to graph it, I suppose I could graph this out of slope-intercept form. So really quickly, before we do this in standard form and talk about the method for doing so, just notice that we could take this. We could say 2x minus 3y equals 6. And remember that slope-intercept form just means we have y by itself. So we could subtract 2x from both sides. We could say, well, this would cancel out. We say negative 3y is equal to 6 minus 2x. And then we could divide everything by a negative 3. And so in this case, I would get just a y on the left. On the right, we have to divide everything on top by this negative 3. So I get a positive 6 divided by a negative 3. It's equal to a negative 2. And I'd say negative 2 over negative 3 is positive 2/3. And what we'll do is we'll actually just write the x off on the side here. So this is the equation, this line that we're about to graph. I would know that I could graph this very quickly. It's got a y-intercept of negative 2 and a slope of 2/3. But the question is, how could I do this in standard form without having to manipulate this to be out in slope-intercept form? Sometimes I may have fractions. So the deal is this. When you graph in standard form, the thing is we only need 2 points on a line to get all the rest of the points on a line since they're predictable. So without having to make a table, without having to put it in slope-intercept form, let's find 2 points on this graph. And 2 very convenient points might be where it hit the y-axis and where it hits the x-axis. Okay, and so here's why I want to say this. This is not this line, by the way, but I'm just drawing in kind of a mock line. The thing here is this. If this were on the x and y axes, these two, supposed points here, what we could say about them is this. This is some y value right here, up at this point. But one thing is for sure, x is 0. Anything on the y-axis has to have an x value of 0, and any point on the x-axis likewise also has to have a y value of 0. It's on the ground, okay? It has some x value. So our method here is going to be to do this, to find the intercept. So it says graphing lines in standard form. It says since we only really need 2 solution points on a line in order to connect the dots and have the rest of the line in its entirety, we say the method we'll use involves finding both the x and y intercepts in the line. So this is really cool. If you want to find x and y intercepts, kind of like we've illustrated up here, the method is going to be this. To find the x-intercept, or where it hit the x-axis, we'll just plug in 0 for y and solve for x. And if we want to find the y-intercept, we'll plug in 0 for x and solve for y. So it's kind of a backwards relationship here. I'm going to take all this stuff out of here, and we're actually going to use this method. But that's just listed down here, and we can see that in general. So here's my my advice. We could say x-intercept. You should keep your work ordered at least to a certain extent. But we say y-intercept. I could use my own advice, so don't think that I do anything special. But we say, okay, so x-intercept, y-intercept. Let's go ahead and write this. We said the x-intercept, we said we are plugging in 0 for y. And to find the y-intercept, we're plugging in 0 for x. And so in the first instance, if we plug in 0 for y, notice that I would get this. We'd get 2x minus 3 times blank. Whoops, let me get that out of there. Equals 6. We're putting in a 0. Okay, that's what we're putting in for y. And I want you to notice that this term would just drop out completely, and what we get left with is 2x equals 6. Now, if I had an equation like 2x equals 6, I could just say, well, dividing both sides by 2, I get x equals 3. Okay. One thing I want to point out is this, and I could have told you this just by looking at the equation, but you get 3. The reason why is because when I look up here and find the x-intercept, imagine that I plug in 0 for y. This term literally drops out, and I'd say, well, 2x equals 6, then x equals 3. We're going to use the same method down here to find the y-intercept. If I plug in 0 for x, it means that this term would just completely disappear. And I get negative 3y equals 6. Well, dividing both sides of that by negative 3, I get y equals negative 2. So I'd say negative 2. And so check out how nifty this is. We could say, well, plot the point, 0, negative 2, which is, left and right none, and then down 2. This is 0, negative 2, and we should label this. We say 0, negative 2. And then we say the point 3, 0 is right 3 up 0, and we say this is our line right here. And again, you should label this 2x minus 3y equals 6. So I'm going to do these last few really quickly here, but I'm just going to list out their intercepts, and you can notice what I'm doing in every single instance of this. I'm putting in 0 for x and 0 for y, and 0 for x and 0 for y, and 0 for x and 0 for y, okay? And then going and solving. So like in this next instance here, we could say, well, what would this be if I plugged in 0 for x? So again, plug in 0 for x, this term drops out. I get 4y equals 4, so y must be 1. And then also here, if I plug in 0 for y, this term would drop out completely, and I get negative 1/2 x equals 4. Now, I do want to comment on this. Negative 1/2 x. Oops, let me put that x up higher. X equals 4. Remember, you have to multiply by the reciprocal. So we're going to take both sides times negative 2, which is going to get this to cancel out. And so we get negative 8. So negative 8. So this quick graph right here would be this. We say negative 8, 0. We go left 8, up and down none. And we say left and right none, up 1. And we could sketch this in, and we say, okay, well, I can clearly see that my x-intercept was negative 8, and my y-intercept was 1. I could label both of these, and I could label the line. But I want to go quickly here. So these last two, I just want to point something out. You'll notice that it is okay to multiply both sides of an equation by the same number, and you'll still have an equivalent equation. So the thing I want to point out here is, well, then likewise, you could also divide both sides of the equation by the same number. So for instance, on this one, what I would recommend is, let's take everything divided by 100. What if I divided the entire left side by 100, the right side by 100? The only reason I say this is because I can chop off the zeros, essentially, on everything. And I would get the same equation would be this. We say 3x plus 7y, and in this case is equal to 21. So to find my x-intercept, that means I plug in 0 for y, goes away. I say 3x equals 21, well then x must be 7. And we say, well, if I plug in 0 for x, I say 7y equals 21, then y must be 3, so we'd say 0, 3, go up 3, draw a dot. Go right 7, draw a dot, that's 2 shy of this last one, which is 9, by the way. And we say, okay, so I have some negative slope thing. Didn't have to make a table, didn't have to put it in slope-intercept form. And then this last one looks really, really kind of ugly. Everybody hates fractions, okay? And we could totally find intercepts by plugging in 0 for x and doing what we just did, which was, up here, multiply by the reciprocal both sides. But, hey, if we can help this, let's try. And what I mean by this is, let's get rid of the fraction first. I know that I tell my students that if you ever have fractions in an equation, what we'll do is eliminate it by multiplying by the least common denominator. And I can think of the LCD between 3 and 2 would be 6. So I'll take both sides times 6, and what we'll see happen is this. I get a new equation. On the right side, I have negative 18. And on the left side, I'd see, well, let's see here. This 6 and this 3 would cross cancel. 3 would become 1. 6 would become 2. So 2 times 2 is 4. So I get 4x. This is on the left, okay? And we say if I were to take 6 times this now, the 6 and the 2 would cross cancel. 2 would become 1, but 2 goes into 6 3 times. So we say 3 times 3 is 9. I get a positive 9y. So this is my equation. It's the same set of solutions. So we'll say, okay, well, if I covered up x, that is, if I plug in 0 for x, I get 9y equals negative 18, which is y is be negative 2 in this case. We say, well, negative 2. And then if I were to cover up my y, to find my x-intercept, you'll notice that I get negative 18 fourths, okay, which I don't have a problem with. We'll just go ahead and write it out. We say, well, simplify this. We get negative 9 halves. And we'll go ahead and write this here. I think we can figure this out. We'd say this is my x-intercept here. It tells me the x value where it hits my x-axis. This is negative 4.5. 1, 2, 3, 4 and a half. So the important thing is that we're actually labeling our points. We say negative 9 halves, comma 0. And then we say this one here would just be down 2, draw a dot. We say this is 0, negative 2. And we say, okay, so I have negative sloped line with those two solution pairs and all the rest of the solution pairs. But that is how you graph a line in standard position. You use what we call the intercept method of graphing. Okay, cool.